Hey, what's going on everyone? I wanted to make this video on LeetCode question 1004, max consecutive ones 3. It's a fun sliding window problem that I didn't get at first, but realized it's really simple once you understand the fundamentals of sliding window. So the description says, given a binary array nums and an integer k, return the maximum number of consecutive ones in the array if you can flip at most k zeros. So in the first example, we have this array here, and k is equal to 2. The two zeros that they flipped here at index 5 and the last index results in the longest subarray of consecutive ones, which is of length 6. And if we're starting from left to right, we can say, okay, 1, 2, 3. So far we haven't flipped any zeros. And once we get to 4, now the length is 4, k is now dropped to 1. We have one more zero to flip. And then now the length is 5. So once we get to this third zero, okay, our number of zeros is actually greater than k. Then what we're going to do is shift the left pointer until the number of zeros is less than or equal to k. Because if it's greater than k, it's going to be invalid. We can flip at most 2 zeros in this case. So we're going to have variable length for the length of the array. And we're going to make an array or a variable called number of zeros and set that equal to 0. Then we're going to have our left and right pointers, which I'll explain their purpose in a minute. And they're both going to be set at the first index. Finally, we're going to need a variable for max, which is the maximum length of consecutive ones that we found. And we're going to set that equal to 0 for now. And that's going to be our return. Okay, so we're going to use 2 pointers here. Our right pointer is going to shift us to find the length, to find a valid length of the subarray we need. And the left pointer is actually going to shift until the number of zeros is less than or equal to k. So while right is less than length, so we're not having an array out of bounds exception. Okay, so the first thing we want to check is, okay, if nums at index r is equal to 0. If we're thinking of the most basic condition we can think of, whenever we encounter a 0, we want to increase the number of zeros, as in the variable that we declared up here. So number of zeros is going to be incremented. Else we don't do anything. We assume that the subarray we're in is valid, right? In the case that it's invalid, so number of zeros is greater than k, this means we're invalid and we're going to have to shift the left pointer up until the point where number of zeros is less than or equal to k. So we want to make sure we're still in bounds. So now that we're focusing on the left pointer, we're going to say left is less than length and number of zeros is greater than k. Okay, so what are we going to do here? Well, we want to decrease the number of zeros every time we find another 0. So if nums at index L is equal to 0, then number of zeros is decremented. Okay, and we just keep shifting the left pointer. Okay. Okay, once we get out of here, we're going to have else. So else means we're inside a valid subarray. We know that number of zeros is less than or equal to k. So what we do is assign max to max and right minus left plus 1. So right minus left plus 1 is the length of the valid subarray that we're currently in. Okay, and all we have to do is increment the right pointer, or else we're just going to get a time limit exceeded exception. And we just return max after that. So we're going to hit run. Okay, right. Oh, I didn't say left, just to make things simple. Okay, so our test cases have passed, and now for the big moment. Okay, so that is complete. Just to summarize, this is one of your standard sliding window problems. We slide the window to make sure we're inside a valid subarray, and we recompute the max variable to ensure that we have the greatest length subarray. Whenever we encounter number of zeros is greater than k, we want to make sure we're sliding the left window to make sure that it is valid. Thank you for watching.